All right, guys, in this video, we are going to be looking at some solubility questions. I've got a free response question and a multiple choice question. So here's the multiple choice question. We got a student places a I2, which is solid, and which is iodine, in 50 milliliters of water. And another piece of I2, which is solid iodine, of the same mass in 50 milliliters of C6H14 and shakes the mixtures. The results are shown above. What do the results indicate about the intermolecular interactions of the substances? So looking at the two before we go look at the multiple choice questions, in this one, the iodine is still a solid and did not mix and create a solution in water. So water, that's telling me, has different intermolecular forces than the I2. And in this one, we form a solution, and it's purple, which tells me it did mix. So that would tell me that I2 and C6H14 have similar intermolecular forces, and that is true. I2 would be a very nonpolar molecule, and C6H14 would be very nonpolar as well. And we have learned that water is very polar, so it makes sense that this would form a solution and this one would not. Or I would say that I2 is soluble in C6H14 and I2 is not soluble in water. So looking for the correct answer of these choices, I2 and H2 have similar molecular reactions, and I2 and CH14 do not. Nope, that's wrong. That's the opposite of what we're looking for. I2 and C6H14 have similar intermolecular reactions, and I2 and H2 do not. That is what we are looking for, so definitely B. C says that they all have the same. That's not true. And D says they're all different. That's also not true. So we were definitely looking for B, just as we were talking about the one where I2 interacts with C6H14 and I2 does not interact with water. Okay, this is a short answer question. Answer the following questions about the following two compounds. We got NH2Cl and NCl3. The Lewis diagrams are shown below. This says NH2Cl is highly soluble in water, whereas NCl3 is nearly insoluble. Explain the observations in terms of types and relative strengths of intermolecular forces between each of the solutes and water. Okay, so the reason why NH2Cl is soluble in water is they have similar intermolecular forces and strengths. Okay, they both can do hydrogen bonding. Remember, hydrogen bonding is based on having a hydrogen bonded to either an oxygen, fluorine, or nitrogen. Also, something that's important is this lone pair that exists right here. It is required also to do hydrogen bonding. So right here, we can see that because they both have hydrogen bonding capabilities, they've got relatively similar strengths of intermolecular forces. Whereas here, it's insoluble with water because it is nonpolar. It can only do dispersion forces, and water can do dispersion, dipole-dipole, and hydrogen bonding, just like NH2Cl can as well. So when you're answering this question, use this information to answer it, something along the lines of H2O is polar just like NH2Cl. They can also do hydrogen bonding, so that makes them very similar. So they are soluble, whereas NCl3 is insoluble with water because they have different intermolecular forces, where NCl3 can only do dispersion forces, whereas water can do hydrogen bonding, dipole-dipole, and dispersion forces. Okay, something along those lines to answer it. You can definitely summarize that a lot better, but that's what you're looking for when answering this question.